Ciao. My Italian is even worse than my Dutch, so we'll stick to English today. Can you blow it up? Okay. I work for NTT Communications, and I'm not here alone today. I brought a friend. Sean, where are you? Stand up. This is also a guy from NTT. I do the drinking, he does the sales. But we're not talking about NTT today. We're talking about an effort that is industry-wide and that concerns each and every internet operator in this room. Large BGP communities. A brief history on BGP communities. I think most service providers use BGP communities in some way or form in their network to allow customers to influence the routing, for instance, to higher local preference or lower local preference, or they use it to prevent leaking peering routes to other peers, or route server operators use them so they can allow route server participants to selectively export or not export to other route server participants. There are many, many use cases for BGP communities. And the format in general is 16 bits followed by a colon, and then again 16 bits. So if we look at some of these examples, for instance, 2914:3200, in NTT's network, this means the route was learned in Europe. 2914:2203 means the route was learned in the Netherlands, and so on and so on. And we've been doing this for 15, 20 years. And we are not the only ones. I assume that you use them, but I know for sure that all the other big carriers use them because they've published documents. Like you cannot read it from the back of the room, but there's Quest and Level 3 and Telia, and there's all these companies that use BGP communities. In fact, BGP communities are so important that some customers demand these capabilities in the commercial agreements. And then a problem came along years ago. About 10 years ago, in the ITF, work was done to extend the ASN space from 16 bits to 32 bits. Because the wise man in the ivory tower foresaw that 16 bits worth of ASNs would not be enough to sustain a healthy, growing internet. So they did a lot of work. They made tricks to make the AS path work. They provided a tricky way for backwards compatibility. The router vendors started coding, and the RAR started assigning these 32-bit ASNs to end users. Fantastic. However, there was one small oversight in this entire process. Nobody thought about BGP communities. And you might realize that if the convention is that if the first 16 bits of a BGP community are the AS number of the network that is responsible for those communities, you cannot fit a 32-bit value in a 16-bit field. It doesn't fit. And this is terrible because at this very moment, roughly 20% of the autonomous system numbers in the default free zone is a 32-bit ASN. And that 20% is deprived of a sensible solution on how to do BGP communities. No longer. The solution is large BGP communities. We've taken the idea of normal BGP communities, fed it some water, gave it some growth hormones, and now we have large BGP communities. We started this roughly half a year ago. We've pumped 11 versions of the specification through ITF. There's a lot of effort, and I want to share some insight in that effort and to sell this idea to you too. Large communities, however, is not the only effort to address the problem of a form of communities for 32-bit ASNs. There has been something called 4-octet AS-specific BGP extended communities. Now, from a marketing perspective, everybody understands that that name is terrible. And the dumb thing here is, extended communities are 6 bytes in length, effectively. That means, what the trick here is that the first 4 bytes are the AS number, be it 2-byte ASN or a 4-byte ASN, and then the last 2 bytes are what you want it to be. But this does not address the problem that operators face, because we prefer to have a design pattern in which we put the AS number inside the community. For instance, if you look at route servers, if you do not want to export your route to a certain participant, you put that participant's AS number in the community. That's how most of us are used to working with this. So the extended communities is still too small. And this RFC is not even meant for internet usage. It was actually meant for layer 3 VPNs. So it's not even the correct technology if you're very strict about it. Another effort was called flexible BGP communities. Very innovative, very smart, but the complexity of the draft basically killed its progression. They were trying to solve a ton of different problems in a single technology, and I guess nobody was really waiting for that. A similar thing happened with white BGP communities. White BGP communities represents 5 years of talking and no coding. And without running code, what can we do? So this brings us to roughly 10 years of no solution. Meanwhile, we are deploying 32-bit ASNs in the wild. Meanwhile, we're struggling to get our networks in working order. So this is complete oversight on part of the IETF. Very, very disappointing. So when we released large BGP communities, I called all my friends and I said, you need to email into the IETF because this is our one chance to make something work and get a standard that will help us the next 20 years. And then everybody showed up en masse. Tens and tens of people emailed in saying, I want large communities. And the pitchforks came out and IETF people were like, whoa, what is happening? Who are all these angry people? That's the back pressure of 10 years of not having a solution. But this was good news, because if there's a lot of support for a standard, then the standard can proceed through the various phases of IETF. And in all of this, we deliver one consistent message. Dear operators, large communities is exactly like the classic BGP communities. It's only grown up, it's bigger. It has exactly the same propagation characteristics. It's an optional transitive attribute. If you type it into routers, it's almost the same. And that is why I think this technology can be successful, because if we would have to re-educate the entire world on an entirely new technology, like if you look at IPv4 and IPv6, I think IPv6 deployment was very much delayed because IPv6 is so different from IPv4. There's no ARP, there's no this, there's this instead, there's blah, blah, blah. And this requires enormous amounts of training and outreach. This is a very costly effort. So we tried to bypass that expensive step with large communities, where we say, it's the same, it's just bigger. And this is all you need to know. You can now go home and implement large communities. So if we look at the design goals of large communities, why is large communities the way it is? One of the very explicit goals is that we can deploy this quick. The specification is so simple that for most open source implementations, a patch to support the technology is between 1,500 and 2,000 lines. So from a code perspective, that is very, very small. And that allows quicker implementations, and that allows for quicker deployments. We'll get to the implementations in a little bit. Another important aspect of large communities is that we can now finally have clean namespaces. That no longer the BGP communities of one provider have a chance of colliding with another provider. I will later on show some examples that illustrate what the namespace means. There are a few things that are explicitly out of scope. One of them is there is no general mapping system between the old communities and the new communities. If you want to map between the two technologies, you have to do that yourself. Every network has different requirements, different philosophies, different community schemes, and we've decided that if we try to create a mapping system, the discussion will not be 7 months, the discussion will be 36 months. And that kills the momentum, that would kill the chances of large communities being deployable. There are also no well-known communities. So for instance, the well-known community no export, or no advertise, or black hole, those communities, we still do that with the old technology. And the technologies, I think, will coexist for many, many years. There's no well-known communities in large. So on the wire, it is pretty straightforward. The first 32 bits are the ASN of the network that owns the namespace. And then the last 64 bits can be whatever you want them to be. Let's go to some examples. In the NTT network, we have a community that is 65400:peer ASN. And then peer ASN is the AS number of one of our peering partners. For instance, AT&T or Sparkle or whoever. And if you put the ASN of that peer behind this specific community, in our network, the following function is triggered. Do not advertise to that peer ASN in North America. Now you can see the problem with 32-bit ASNs. NTT at this moment is literally incapable of peering with a 32-bit ASN because you cannot fit 32 bits in this 16-bit field. However, with large communities, that community would look like this. 2914:65400:peer AS. And the intriguing part is because each of these fields is 32 bits, we can now finally put a 32-bit ASN in that field, and we could support peering with 32-bit ASNs. The Amsterdam Internet Exchange route server has a function 0:peer AS. And if you put the ASN of a different route server participant in that field, so for instance 0:8283, one of the route server participants, that would prevent the route from being exported to that ASN. But again, we see you cannot fit a 32-bit ASN in that field. It doesn't work. But with large communities, you could have 6667:0:peer AS. And the beauty is, in the first instance, this 65400, that is actually a private ASN. Should NTT at some point acquire a network and they also use that community but for a different purpose, there is a clash. Private ASNs are not unique. Everybody can use them. But with large communities, you can see that we prepended the whole thing with 2914, and that is our namespace. NTT decides whatever comes after the colon. And the same goes for AM6. They were using 0, which is not an ASN. Anybody could use that. But now they can put it inside their own namespace because their route server ASN is 6667. And it would prevent collisions with, for instance, people that peer with multiple route servers on multiple internet exchanges that have the same community scheme. So finally, with large communities, There will no longer be collisions because you do not need to put stuff in the communities with private ASNs. And the examples go on and on. If we look at the progress this draft has made, there's a little bit of reason to celebrate, because yesterday the draft passed what is called IETF Working Group Last Call, and is now in almost the final stage before RFC publication. I expect, if all goes well and there are no more obstacles, that we might be looking at an RFC publication as early as January, maybe February. And that is good news, because the moment it is an RFC, then operators can actually reference the standard document and say, dear router vendor, this is what I want, and you have to implement it because this is the standard. The effort, however, it's multiple parallel efforts, really. There's the IETF side of things, where we need to work towards getting a standard document out. But there is also the implementer side of things, where companies like Cisco and Juniper or Nokia have to work internally to not only implement the feature, but make sure that the feature is what customers would want it to be. For instance, we want regular expression matching. We want to be able to set and add and delete communities. We need diagnostic commands, such as show BGP, large community, and then whatever you want it to be. They need to update their documentation. They need to do internal sales training, technical sales training. The tags need to be trained as well. There's, inside these implementer organizations, it's a very big effort to push a new standard like this. And then there is the third track, the network operators, you and I. We need to redo parts of our routing policies in context of large communities. We need to test our policies. And we, again, need to educate our customers, saying, hey, customer, you used to use BGP communities for this, but now you can use large BGP communities to do the traffic engineering. So the whole industry, all aspects of it, the whole ecosystem, needs to adapt to this idea. And even though the idea is very simple, the effort to do something like this is gigantic. It's like trying to turn a supertanker. On the BGP implementation side, I have very good news. Cisco IOS XR already has beta images that are not for public release, but they've proven that they have the feature implemented. BIRD, our favorite route server software, has support for large BGP communities in their master branch. ExaBGP is there. Juniper is probably going to support large communities in the second half of 2017. Nokia is working on it. OpenBSD supports it. GoBGP supports it. Quagga, we are working on a patch. There is a beta patch available if people are interested in testing. The IETF requires 2 implementations, but to be on the safe side, we thought that 7 is better, and that is growing. And there is also somebody I would like to thank specifically. Pierre, where are you? Stand up. This guy has single-handedly tested all the open source implementations, whether they were compliant. Give him an applause. No, this is fantastic, because IETF requires that you prove that things are interoperable with each other, that they work together, that different vendors can talk the same standard to each other. And having that proof in your hands is a huge accelerator for the process. So, well done. If you go to largebgpcommunities.net, you can track the latest and greatest information on this effort, and that's where we keep the list of all the implementations that we know of. But it's not just about routers. You need the whole ecosystem to support large communities. So DKIX has a PCAP analyzer that can be used to debug BGP streams, supports large communities. TCP dump on FreeBSD has been provided with a patch, so that if you have TCP dump decoding that you can actually see the large communities in a human readable format. The same goes for TCP dump on OpenBSD. The official TCP dump package has also been updated. Wireshark has merged support for large BGP communities, and PMACCT also supports large communities. And this is very important because, for instance, PMACCT, the way NTT uses it, is that we correlate the flow data with the prefix, with the BGP communities and the AS path, and that together gives us the business intelligence information that we need. For instance, in PMACCT, we use markers such as this came from a customer, or this came from a peering partner, and we know this because the BGP communities are attached with the prefix. And likewise, if large BGP communities takes off, all the infrastructure, all the statistics systems, all those little details, they need to support it as well. If you want to help with some preliminary testing, I am announcing two prefixes, 192.147.168.0 and an v6 prefix, and those prefixes have the large community attached. And it would be good to verify that you see the prefix, and if you see it, that you see that the attribute is attached. And it's not really readable, but if on an iOS device you would type show IP BGP 192.147.168.0 and press enter, it will give you information that says unknown transitive attribute and then some hexadecimals. And if you see that, that's good. If you do not see that, contact me. So there are basically two to-do lists. One is for the implementers, where implementers need to make sure that large BGP communities is actually usable. As I said, you need the diagnostic commands, you need regular expression. It needs to be a first-class citizen of the routing policy language. But the second to-do list is more interesting, and this is the to-do list for you. I would ask you to email your router vendors, preferably today, and ask your account managers, hey, I saw this large BGP community thing, I want you to support that. Because even though a company like Cisco or like Nokia have committed to implement large communities, they have many things to work on. Of course, there are many customers with many features. So the louder we scream and the more and more people different from each other ask for the feature, the higher it gets on the priority list, which is good for all of us. So strength is in numbers. It is not good enough if only NTT asks Cisco to implement it. We need hundreds of people to ask them to implement it. So take that as your to-do item for today. Email your account manager, tell them this is what I want. And then when the vendor has done their part, we can work on our part and do the network automation and upgrading the routing policies and training our own staff and thinking about designing community schemes. But that part will be, say, a year from now. The part that starts today is asking your vendor. So this basically concludes the presentation. The key message is it's just like the old communities, and hopefully end of 2017 there will be running code on all the big platforms of production quality. So that's basically the timeline you need to keep in mind. A small note, reuse of this presentation is encouraged. Email me if you want the master deck, then I will email it to you. You can translate it, you can modify it, you can have it for free. It is very crucial that we spread this information to as many operators as possible. So if you have a local or regional event, use these slides, please. Anyway, this is it. Time for questions. Really? No questions at all? All right. Thank you.
Thank you, Job. Okay.